Hello and welcome. In this series, you'll learn advanced uses of condition nodes to simulate smarter characters and scenarios. In today's tutorial, we'll focus on how to check the distance and range between two objects or characters. An automatic door is a great example. There are two types of nodes you can use for range detection. The check distance node measures the exact distance between objects, allowing the door to open when a character gets close enough. Alternatively, the check zone node uses a trigger zone to detect whether a character has entered a defined area, opening the door once the character is inside the zone. First, navigate to Content Manager, Project, MP Set, and locate the MP Set Factory Pack. You'll find the production floor planning set there. Load it into the scene. Let's focus on the section where the handler places products onto the conveyor belt. Start the motion director to see the result. The red handler first picks up a product and places it on the conveyor belt. Then the logic takes effect. The machine operator begins operating the machine when a product comes near. When the product moves farther away, the operator returns to the idle state. This behavior can repeat indefinitely thanks to the check distance node. The worker is machine operator 1. Open the motion planning node graph to view this worker's script. Focus on the conveyor belt process group node. Here, you'll see the subgraph for machine operator 1. You can also use the search function if you have trouble locating specific nodes. Double-click to enter the subgraph. Let's examine the first half of this workflow. The workflow begins with a Go-To node, which moves the character to the processing machine position point. Next is the Check Distance node. Select it to view its detailed settings in the Attribute panel. This node detects the distance between two targets, Target A and Target B. In this case, Target A is set to processing machine 1, Target B is set to the conveyor belt. The conveyor belt contains multiple placement points for products. This allows the check distance node to monitor the distance between the machine and any product on the belt. Below, you can define the condition as lesser or greater and specify the distance threshold. In this example, when the distance between processing machine 1 and any product on the conveyor belt is less than 230 centimeters, the condition evaluates as true. You can also set target parts to all, meaning all products must be within 230 centimeters to satisfy the condition. When the condition is true, the operator plays the operate machine motion. Otherwise, the operator remains idle. Before continuing, let's customize the operating motion to better demonstrate the check distance function. In real factory scenarios, operating motions may vary. We provide complete tools for customizing MD props. Select Processing Machine 1, open the MD Behavior window, and switch to Behavior Settings to view its original motions. Hover over a motion to preview it. Let's assume we want to shorten the operating motion. Click Add, Delete Behavior, select a character for preview, and enter Behavior Edit mode. Right-click the Operate Machine motion and choose Edit Motion in Timeline. Now you can preview and edit the motion in the timeline alongside the prop animation. Press Ctrl+B to break the original motion clip, then adjust and blend it smoothly using the timeline editing tools. After editing, preview the result. You'll see that the new motion is shorter. If satisfied, select all desired clips, right-click, and choose Select Collection Range by Selection, then right-click the selected range and choose Overwrite to update the original behavior. Click Save when the prop trigger window appears. Now restart the motion director. You'll notice the operating motion is shorter. However, since the trigger distance remains the same, the motion may finish before the product fully enters the machine. This means we need to adjust the node graph. Reopen the motion planning node graph. Dock the window to the left panel for better interaction with the viewport. Enter the machine operator 1 subgraph again. Currently, target A is set as processing machine 1 and target B is conveyor belt. The distance amount is 230 centimeters. Because the shortened motion is triggered too early, we need to reduce the distance threshold. But what should the exact value be? This is where the calculate current distance function becomes useful. To measure the precise distance between two targets, we need to switch target B from the general conveyor belt to a specific placement point. Select one of the placement items and move it to the exact position where you want the operator to begin operating. Then return to the node graph and change target B to put on conveyor belt 1. Click Calculate Current Distance to measure the exact distance. The pop-up window shows the current distance approximately 167 centimeters. After noting the value, undo the temporary adjustments to restore the original setup. Then update the distance threshold to about 170 centimeters, or another value close to the measured result. Now, whenever a product on the conveyor belt comes within 170 centimeters, the operator will begin operating the machine. Start Motion Director again to see the final result. The trigger timing is now more accurate and better aligned with the shortened motion. The operator only begins operating when the product is truly close enough. This process can continue indefinitely thanks to the powerful check distance system. It can be applied across many production workflows, enabling smarter and more responsive worker behavior within your simulation. If we let the simulation run for a longer time, you'll notice that the operator eventually enters idle mode and starts doing other tasks after finishing all incoming products on the conveyor belt. This is where the check zone node comes into play. It allows accurate detection of when the work is truly finished. This works because there is a trigger zone set up in the scene. By combining this trigger zone with the check zone node, we can easily detect whether one or multiple objects are still inside the zone. Once all placement points on the conveyor belt have exited the trigger zone, the worker recognizes that the task is complete and is allowed to enter idle mode. Open the node graph and enter the machine operator 1 subgraph again. This time, let's focus on what happens after the operate machine motion. You'll find a check zone node there. Select it and look at its settings in the attribute panel. The zone is set to range machine operator 1, which is the trigger zone we saw earlier. The entity is set to the conveyor belt, with target parts set to any. This means the node checks whether any objects under the conveyor belt are still inside the trigger zone. If at least one placement point is still inside the zone, the result is true, and the workflow loops back to the operator's working state. If no placement points remain inside the zone, the result is false, and the operator transitions into idle mode to perform other actions. Now let's extend this workflow further. Assume we introduce a new white supervisor character into the scene, who constantly patrols the area. In this case, machine operator 1 should remain alert even after all products leave the zone. The operator is only allowed to enter idle mode when the supervisor is no longer nearby. To achieve this, first go to Menu, Create, Path, and draw a path for the supervisor to walk along. Next, create another trigger zone to detect whether the supervisor is approaching. Go to Create again and select the Trigger Zone tool in iClone 8.7. A small green gizmo will appear in the scene. Drag it to the desired location and adjust it in the Modify panel. In the Trigger Zone settings, you can define the zone shape. Circle allows you to adjust the radius, while rectangle allows you to adjust the X and Y size independently. In this case, increase the Y size to fully cover the supervisor's detection area. Now let's quickly set up the supervisor's workflow. In the node graph, right-click on an empty area and add a start node. Connect it to an auto-move node. This node allows a character to move along a path or within a defined area. Select the auto-move node and keep mode set to auto on path. Assign the space as the newly created path and set the character to the supervisor. Increase the duration to a large value, such as 3,600 seconds, so the supervisor can patrol continuously. That's it. The supervisor's behavior is now set up. Now let's return to Machine Operator 1. Originally, once all placement points left the zone, the operator would immediately enter idle mode. Hold Alt plus left click to remove the existing false connection. Then press Ctrl plus D to duplicate the check zone node and connect it to the false output. For this new check zone node, let's change the zone to the newly created trigger zone using the eyedropper and set the entity to the supervisor. This node now checks whether the supervisor is inside the zone. If the result is true, the operator cannot rest and will remain on standby. If the result is false, meaning the supervisor has left the area, the operator is finally allowed to enter idle mode. That's it. Let's look at the result. The red handler continues placing products onto the conveyor belt. To better visualize the behavior, open the MD Controls panel and enable Show Trigger Zone Gizmo. When the last product is placed on the conveyor belt, the machine operator starts operating the machine. This time, even after the product leaves the original trigger zone, the operator remains in position. This is because there is now an additional condition. The supervisor must also be out of the zone. Once the supervisor leaves the area, the operator finishes his task and finally enters idle mode to do other activities. By combining check distance and check zone nodes with trigger zones, your characters can precisely respond to object proximity, work completion, and environmental conditions. This layered logic enables more intelligent, flexible, and scalable behaviors, whether coordinating machines, workers, or supervisors in complex production simulations. That's all for today. Thanks for watching.